Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry. In this series, this will be the lecture of IR spectra and this is lecture number 11. In this lecture, I will explain the factors affecting the shapes and frequency value of IR bands. Okay, so first of all, let us see the factors affecting shape of bands. There are two types of shapes. Particularly with respect to bands. The first one is broadband, for that we write BR, and second one is sharp band, for that we write SH. Okay, so let us take first of all broadband. The band is normally huge like this in the graph, and when molecule has OH or NH group or NH2 group rather, which form intermolecular hydrogen bonds, it shows broadband. Okay. Even more polar molecules shows broadband. For example, carboxylic acid group, in which there is C double bond O as well as OH, and you will see that this band is like this, ranging from 3300 to 2500 centimeter inverse, or like this nearly at 1700 centimeter inverse. This indicates the presence of COOH group. Even COC groups, ether, in which you will see the band like this, ranging from 1300 to 1100 somewhere, or maybe less than that, and it is known as zinc band. So this is because of polarity. So broadband appear due to either hydrogen bonds or polarity. Second type of band is known as sharp band, which will be like this. Okay, it looks like knife. When a molecule is non-polar, which produce induced polarity, in presence of IR radiations. That means they are non-polar in normal condition, but when IR is absorbed, they become polar because of the difference in bond length. Such molecule gives sharp band. Okay. Or there are certain groups which will observe, you will observe sharp bands like C double bond C, alkene, and you will observe sharp bands like this, which will be of medium and sharp, okay, at 1680 centimeter inverse. Another is C triple bond C. It will be also very sharp but weak at nearly 2100 centimeter inverse. Okay. In case of CH group, which is not quite polar, you will observe bending in CH2 at 1465 centimeter inverse. So normally such groups produce sharp bands. Or if any functional group which is polar but will not give interactions and give hydrogen bonding, they also give sharp bands. Okay, so this is about sharp bands and broadband or factors affecting shape of molecules. Now we will see factors affecting or influencing wave number or frequency. That means the position of band in IR spectra is related to certain factors. You know, vibrations of molecule follows Hooke's law. You must have studied Hooke's law in physics. Okay, and there is very famous equation for that, that mu bar is equal to 1 upon 2 pi c into root k upon mu. Okay, here this is wave number, and therefore the unit will be centimeter inverse. K is known as force constant. You will derive this equation in physical chemistry, molecular spectra. And mu is not something else, but it is called reduced mass. And mu is equal to m1 m2 upon m1 plus m2. This has nothing to do with dipole moment, remember this. Okay, so here mu is equal to reduced mass. So if we observe these equations, then we will see that wave number is directly proportional to k, that is force constant, and wave number is inversely proportional to reduced mass. So first of all, we will see the factor mass. Particularly reduced mass. Okay, so if reduced mass, that is mu, increasing, then you know it is inversely proportional, so wave number will decrease. For example, CH bond, in which m1 will be the mass of carbon and H2 will be m2 will be the mass of hydrogen. Okay, and we will observe, as reduced mass is this much, according to this formula, we will find out frequency is about 3000 centimeter inverse. But if there is a bond between carbon and deuterium, where m1 is equal to carbon and m2 is equal to deuterium, which is a little bit heavier than hydrogen, then the frequency will be this at 2100 centimeter inverse. And very important example for influence of mass is on carbon halogen bond. If CCl bond, here M1 will be carbon and M2 is chlorine. In this case, the band is nearly 600 to 800 centimeter inverse. If the bond is between carbon and bromine, where M1 is carbon, M2 is bromine, reduced mass will be increasing. So here you will see that band will be at about 550. And if there is a bond between carbon and iodine, M1 is carbon, M2 is iodine, here again a reduced mass increase and the band will be below 500 centimeter inverse. So this is the influence of mass. You can see this. Okay. Now the second one, influence of force constant according to Hooke's law. Look, force constant is related to bond strength. So if force constant is high, that means bond strength will be high. And if bond strength increases, it is directly proportional to wave number. So here we can say that K is directly proportional to frequency, and therefore K increases, bond strength increases, wave number also increases. Best examples are C single bond C, where frequency is about 1000 to 1200. Okay, C double bond C, where frequency is about 1600 to 1660. Why? Because bond strength increases. C triple bond C, then again nearly 2200. So here you can see from downward, as bond strength increases, then wave number also increases. Similar example is of C single bond N. For amines it is about 1000 to 1200. If there is C double bond N, then it is nearly 1650, and if it is C triple bond N, you will find absorption at 2200 centimeter inverse. Okay. Similarly, C single bond O at 1000 to 1300, and if there is C double bond O, which will be at 1700. So this shows that as K increases or bond strength increases, frequency also increases. So these two factors are related to physical chemistry, that is force constant and reduced mass. There are so many other factors which I will explain you in next lecture. That's it in this lecture. Thank you so much.